Hello guys, today we are going to start solved examples on Cauchy integral formula. Here are some remarks, that is, number 1 is the Cauchy's first integral formula can be written as integral over c fz over z minus z naught dz equals to 2 pi iota f of z naught. Then is Cauchy integral formula, which can be written as integral over c fz over z minus z naught the power n plus 1 dz is equal to 2 pi iota over n factorial. Now is your nth derivative of f of z naught. Let's start with the examples now. The first one is evaluate integral over mod z is equal to 3 e the power z over z minus 2 dz. Here your mod z is equal to 3 means it is a circle which is centered at 0. That means this is your circle which is centered at 0, having the radius 3. 1, 2, 3. Right? Now the f of z is what? E the power z. It is given now. So let's start with the solution. Your f of z is, let f of z is equal to e the power z. Then check. Now what is your point? Your point is 2. Your z naught point is 2. Remember that we have integral over c f of z over z minus z naught. So here your z naught is 2. So we have to find f of z naught because we need this f of z naught in our Cauchy's first integral formula. Why we are using Cauchy's first integral formula? Because in the denominator we don't have any power that is greater than 1. If the power is greater than 1, that is if 2, then we can use the Cauchy's integral formula. Right? Now here the power is 1. So here only Cauchy's first integral formula is used. So your f of z is e the power z. Then what is your f of z naught? That is f of 2. This is equal to, put 2 over here, this is e square. Right? Now fz is analytic inside the circle and on mod z is equal to 3. It is analytic inside and on mod z is equal to 3. And the point, this 2, z naught, your z naught is 2. Is this point lies inside the circle? Yeah. Because the radius is 3, so this point lies inside the circle. Right? So since fz is analytic inside and on mod z is equal to 3 and the point z is equal to 2 is inside mod z is equal to 3. So by Cauchy's first integral formula, we have integral over, what is our c contour? C contour is mod z is equal to 3 and e the power z over z minus 2 dz. This will be equal to, this can be written as mod z is equal to 3. Instead of e the power z we have f of z. This is f of z over z minus 2 dz. Now using this formula which we have read as a remark, this is equal to 2 pi iota f of z naught. Z naught is 2. So f of 2, which is equal to 2 pi iota e square. This is your solution. Okay. So just we have to check whether the power of the denominator is 1 or greater than 1. If it is 1, then we have to use Cauchy's first integral formula. If it is greater than 1, then we have to use Cauchy's integral formula. Second thing is, you draw the circle which is given to you, as if here mod z is equal to 3 is given. You have to draw that circle and check whether this point z0, that is 2, lies inside the circle or not. If it lies inside the circle, then we use the formula, and if it's not, if it is outside the circle, then we have to skip that point. We have to apply the formula only for that points which lies inside the circle. Furthermore, examples will clear this. Next one is evaluate mod z is equal to 3 e the power z square over z minus 2 whole square. Now here the power is greater than 1. Now we have to use the Cauchy's integral formula. And also the circle is given again, mod z is equal to 3, which is centered at 0. Now is this point z0? Z0 point is 2 here. Is this point lie inside the circle? Yes, of course. So let's start. So now here, let f of z is equal to e the power z square. Then what is your f of z0? That is f of 2. This is equal to e the power z squared into. Now see, we have to find, because power is 2 here, so we need f dash 2, right? In the formula, if you remember the Cauchy's integral formula, if the power is, if you have your nth derivative, let's see here. Now here it is n plus 1. What is your n plus 1? It is given to be 2, right? So what is your n now? N is equal to 1. Okay, so we have to find f dash z0. Is it clear? Here the power is 2, that means n will be 1, and we need f dash z0 in the example which we are doing. Sorry, wait. So that's why first we have to find the derivative of fz. So what is f dash z? It is e the power z square into 2z. Now find f dash z0, that is 2, which is equal to e the power z square into 2z, that is, this will be 4. 4 e the power z square, right? Now since again we have to write, since f of z is analytic inside, because if fz is analytic, then only the Cauchy's integral formula applied, and on mod z is equal to 3, and the point z is equal to 2 lies inside, mod z is equal to 3. So by Cauchy's integral formula, what we are having, integral over mod of z is equal to 3 e the power z square over z minus 2 whole square dz. This can be written as, this is f of z over z minus 2 whole square, which is further equal to, applying the formula you will have 2 pi iota over n factorial. N is 1, so it is 1 factorial, and f n z naught, so n is 1 and z naught is 2. So this is equal to 2 pi iota, and f dash 2 we have found, that is 4 e the power z square. Further it is 8 pi iota e the power z square. Easy? Okay, next. Sorry, here it should be e the power 4. E the power, z is 2, so this should be 4. I'm very sorry for that. This is also 4. E the power 4. Okay, so next. The third example is, if pz is a polynomial of degree n, now the polynomial is given, prove that integral over mod z is equal to 2, pz over z minus 1 n plus 1 2, this is your power n plus 2, dz is equal to 0. So what is the function fz? That is your polynomial at z pz, and in the denominator z minus 1 the power n plus 2. We are having z naught point as 1, and it also lies inside this circle mod z is equal to 2, and denominator power is given to be n plus 2. So what is your n? What you have to find? We have to find which derivative of pz? We have to find n plus 1th derivative of pz. So since nothing to do, just write, since pz is a polynomial of degree n, so we have to find the derivative of pz, but which derivative? N plus 1th derivative. Because if you are having power 2 here, we have to find the first derivative. If the power is 4 here, we have to find the third derivative. Just one less. If you are having the power n plus 2, then we have to find the n plus 1th derivative. Okay. So what is the n? Now this is equal to, as this polynomial is of degree n, so the further more degree n plus 1th one, that derivative will be 0. Okay, so the derivative for pz, the n plus 1th derivative for pz will be 0, because pz itself has a degree n. So next, that is p n plus 1 at z, this is equal to 0. Therefore p n plus 1 at, what is the point z naught? That is 1. This thing is also 0. Okay, now since pz is a polynomial that is analytic inside the circle and on the circle, and the point z equal to 1 lies inside the circle. Again, since pz being a polynomial is analytic inside and on mod z is equal to 2, and the point z is equal to 1 lies inside it. So by Cauchy's integral formula, we are going to have mod z is equal to 2, This is nothing but your Bz will be Fz over z minus 1 n plus 2 dz. This is equal to 2 pi iota into over n plus 1 factorial. And here it is Pn plus 1 z, which is 0. So whole thing will be equal to 0. Is the concept clear of n plus 1 derivative for Pz? Obviously, if suppose you are having 2x square, this is a polynomial for of degree 2, okay, plus 1. So this is a polynomial for degree 2. That means the third derivative will be 0. See, the first derivative is, suppose this is f of x. The first derivative is 4x. The second derivative is 4. Then the third derivative, obviously it is equal to 0. Whenever you are having a degree n, then always n plus 1 derivative will be 0. Now is it clear? Okay, next. This is a quite interesting one. Now here it is given that your integral over the circle mod z is equal to 2 and 1 over z square plus 1 dz, it is given. Now how to solve this? What is your fz here? Your fz here is 1, okay, and the points will be, let's separate this first. Integral over mod z is equal to 2, 1 over z square plus 1 can be written as, wait, z plus iota and z minus iota, is it? Okay. Now here 2 points are there. One is iota and one is minus iota, and both these points lie inside the circle. I have drawn mod z is equal to 2. This is your real axis and this is your imaginary axis. Okay. Furthermore, how to separate this? Should I tell you the trick? Okay. Just you write first the denominators. Z plus iota, z minus iota. Okay. Put z plus iota equal to 0. That is, z will be equal to minus iota. Hide z, because you have putting this thing is equal to 0, that is z plus iota equal to 0. You have to hide this and putting minus iota over here. What you will be get? Minus 1 by 2 iota. So this will be minus 1 by 2 iota. Okay. Similarly, the second one. Just if now we are taking the z minus iota, put z minus iota equal to 0. What you will get? Z is equal to iota. Now we are taking this denominator, then you have to hide this denominator and put z equal to iota over here, z plus iota. So this will be 1 over 2 iota. So this is 1 over 2 iota with positive sign. Whatever denominator you choose, you just put that equal to 0, get the value and put in the above expression, hiding that denominator. Okay. Fine. Next, this is equal to taking 1 over 2 iota outside, 1 over 2 iota, integral over mod of z is equal to 2. We are having 1 over, I'm writing the second one first, then 1 over z plus iota. Okay, fine. Now we are having the two integrals, the first one and the second one. We have to solve these two both, because iota and minus iota both lies inside this circle. Now what is your fz over here? Fz is 1. So let f of z is equal to 1. And since iota lies in, now here power is 1, that means we have to use Cauchy's first integral formula. Okay, so since iota lies inside the circle, we have to find f of iota, that is equal to also 1. Similarly, in the second one we have fz is equal to 1 and minus iota also lie inside the circle. So we have to find f of minus iota, which is also equal to 1 because f of z itself is 1. There is no z over here. So f of minus iota is also a constant, that is 1. Now, can you write this line on your own that since f of z lies inside the circle and on the circle mod z is equal to 2 and the points z equal to plus minus iota lies inside the circle. These 2 points lies inside the circle. So by Cauchy's first integral formula, you have to write those lines again and again in every question, because by writing these 2 lines then only you can use the Cauchy's integral formula. Without that you can't use this formula. For that fz should be analytic. You have to write that again and again. So by Cauchy's first integral formula, we are having mod of z is equal to 2, 1 over z square plus 1 dz, which is equal to 1 over 2 iota, the first integral, 1 over z minus iota. Then is the second integral, 1 over z plus iota. Just use the formula now. This is 2 pi iota into f of iota over 2 iota minus 1 over 2 iota and 2 pi iota into f of minus iota. If you calculate this, you will get pi minus pi, that is equal to 0. All things will be cancelled out. Okay, next. Fifth one, evaluate integral over mod z is equal to 1 over z to the power 4 minus 1 dz. Alright. Very similar case. Integral mod z is equal to 2. How can we separate z to the power 4 minus 1? Can this be written as z square whole square minus 1? Using a square minus b square, you will get z square minus 1 and z square plus 1. Because a square minus b square is a minus b and a plus b. Your a is z square and b is 1. That thing I have used. Then further this is equal to, okay, now separate these two. How can? Again, writing the denominators separately. First one z square minus 1, then is z square plus 1. Okay, now putting z square minus 1 equal to 0, you get z equal to 1. Hide this z square minus 1, put z equal to 1 over here, you will get 1 by 2. So this is 1 by 2. Again, putting z square plus 1 equal to 0, what you get? Z square is equal to minus 1. Hide z square plus 1 and put the value for z square equal to minus 1 over here, second one. So this will be minus 1, that is minus 1 by 2. So this is minus 1 by 2 dz. Alright, taking 1 by 2 as common, this will be 1 by 2 integral mod z is equal to 2. This is 1 over z square minus 1 dz minus 1 by 2 integral mod z is equal to 2 1 over z square plus 1 dz. Next, again we have to separate this denominator. This will be 1 by 2 integral mod z is equal to 2. This is 1 over, now again a square minus b square, this is z minus 1 and z plus 1, right, dz, and this will be separated into iotas, that is 1 over z plus iota and z minus iota. Fine. Okay, again we have to separate these two parts. So this is z minus 1, this is z plus 1. Putting z minus 1 equal to 0, you get z equal to 1. Put that, hiding this z minus 1, put 1 here. This will be 1 by 2 again, and this will be minus 1 by 2. Similarly, you can do this. This will become 1 over 2 integral mod z is equal to 2. This will be 1 over 2 iota and minus 1 by 2 iota for z plus iota. Just taking 1 by 2 common, 1 by 4 integral mod z is equal to 2 1 over z minus 1 dz minus 1 by 4 integral mod z is equal to 2 1 over z plus 1 dz. We are having now 4 integrals, minus 1 by 4 iota integral mod z is equal to 2 1 over z minus iota dz, and at the last plus 1 by 4 iota integral mod z is equal to 2 1 over z plus iota dz. Alright, now if you calculate, now what is your fz here? Fz is 1 in all the 4 integrals. When you calculate all these, you will use your Cauchy's first integral formula over here, and also you have to mention that this plus minus 1 and plus minus iota, all these points lie inside this mod z is equal to 2, and then you will use by Cauchy's first integral formula. Alright, okay. So next you will be getting, since f of z that is equal to 1, then f of 1, f of minus 1 all is 1, and f of iota, f of minus iota, this is also equal to 1. So f of z is analytic inside and on mod z is equal to 2, and the points z equal to plus minus 1 and z equal to plus minus iota lies inside mod z is equal to 2. So by Cauchy's first integral formula, because all the denominators having the power 1, mod z is equal to 2, 1 over z the power 4 minus 1 dz. If you apply now, you solve all these separate ones, you will be getting 1 over 4 2 pi iota minus 2 pi iota minus 2 pi plus 2 pi. All those cancel with each other and the final answer will be 0. Just calculate on your own. Next is evaluate integral over mod z is equal to 3, and now your fz is z cube plus 3z minus 1 over z minus 1 z plus 2 dz. How to do this? Now here the fz is not 1. Just do like before we have done. Just separate the denominators and find your fz and the f at the point z0 for both these two denominators. So evaluating this, now integral over mod z is equal to 3. In this case, just separate the denominators like before. Putting z minus 1 equal to 0, that is z equal to 1, hiding this z minus 1, put z equal to 1 over here. This will be 1 plus 2, that is 3. So this is 1 over 3. And fz remain as it is. Can I write 1 over 3 as like this? Okay. Then z plus 2 equal to 0. That is z equal to minus 2. Hiding z plus 2 and putting z equal to minus 2 over the second denominator, that is minus 1 by 3. So this is minus 1 by 3. And your fz remain like this. You don't have to put the points in fz. Remember this. Now separating these two, you get 1 over mod z equal to 3. Taking 1 by 3 outside, integral mod z is equal to 3 z cube plus 3z minus 1 over z minus 1 dz minus 1 integral over mod z is equal to 3 z cube plus 3z minus 1 over z plus 2. Now your circle is mod z equal to 3 and the point z equal to 1, that is 1 lies inside 3. Here also the circle is mod z equal to 3 and minus 2 also lie inside the circle. Okay, see, this is 0, this is 1, this is 2, this is 3. This will be minus 1, this will be minus 2 and this will be minus 3. So this minus 2 points lie in this circle, right? So what we are using now the Cauchy's first integral formula for this. Denominator, the power for the denominator is 1. So now what is your fz? Fz is z cube plus 3z minus 1. And here the point f of 1, that will be equal to, putting z equal to 1 over here, 1 plus 3 minus 1, that is 3. And here also f of z is z cube plus 3z minus 1. And the point is, z0 point is minus 2. F of minus 2 will be equal to, this is putting just put z equal to minus 2 over 3. Just put z equal to minus 2 in this. This will be minus 8 minus this is 6 minus 1, which is equal to minus 15. Right? Now using the Cauchy's first integral formula, we have to write before, that is f of z, since f of z is analytic inside the circle mod z equal to 3 and on the circle mod z equal to 3, and the points 1 and 2 lies inside the circle. Therefore, by using the first integral formula, Cauchy's first integral formula, we will be having, just use over here, this will be, now this is your fz, write fz over z minus 1 dz minus 1 by 3 integral mod z is equal to 3. This is fz over z plus 2 dz, which is equal to 1 by 3 2 pi iota into f of 1. And what is your f of 1? That is 3 minus 1 over 3. This is 2 pi iota f of minus 2, and f of minus 2 is minus 15. And your final answer will be equal to 12 pi iota. 3 cancel, this is 5, and this will be 10 pi iota plus 2 pi iota, that is 12 pi iota. Okay, you can calculate this. Next, evaluate integral over c z over 16 minus z square and z plus iota dz. Can you do this? You just have to separate them and just check the points. Now circle is given to be mod z is equal to 2. Okay, now what are the points over here? The points are z equal to, see here in this case, z is, first just separate this, this will be 4 minus z and 4 plus z, and here it is z plus iota. Minus iota lies inside to circle mod z is equal to minus iota lies inside, but plus minus 4. Can you write this as z minus 4 and z plus 4, taking minus side outside? Now the points plus minus 4, these 2 points does not lies inside mod z is equal to 2 because radius is 2. These points lie outside this circle. So we just have to use only z plus iota for using Cauchy's integral formula. We don't have to use the formula for this second denominator because these points does not lie inside this circle. So just rewrite. Now here your fz is, what will your fz now? Because we are not using this denominator, so your whole fz will be, you take your fz to be z over 16 minus z square. This thing is very important. The points which lies outside the circle, include that denominator with your fz. Okay, so your fz will be z over 16 minus z square. Okay, and since this point minus iota lies inside the circle, we need f of minus iota. Just put here minus iota. This will be minus iota over, this is 16 minus iota square, that is 17. Fine. Now, since f of z is analytic inside and on mod z is equal to 2, and the point z equal to minus iota lies inside circle. Mod z equal to 2. So by Cauchy's first integral formula, Cauchy's first integral formula, I'm writing CIF for Cauchy's first integral formula. Okay, this will be your first integral formula. So Cauchy's first integral formula, that will be then Cauchy's integral formula, right? Okay, so integral over C, take this as your fz over z plus iota dz. This is equal to 2 pi iota f of minus iota. Okay, so finally it will comes out to be 2 pi over 17. Okay, next. Evaluate integral over C 1 over 4z square minus 9 dz, and the circle is given as mod of z minus 1 equal to 1. Circle is changed now. Now the circle is centered at 1, not at 0, okay? So first, let's check what are our points. Can we write, first we take for outside, and you will be getting z square minus 9 by 4. Now what are the points? Z minus 3 by 2 and z plus 3 by 2. We have the points minus 3 by 2 and, plus 3 by 2 and minus 3 by 2. Remember, why I am saying like this? Because we are having z minus z naught. So by considering this thing, for the first denominator, we have the point 3 by 2. Z naught is 3 by 2. And here z naught is minus 3 by 2. Okay, some of the students may get confused. Just check this z minus z naught, and by considering this, for this z minus 3 by 2 you are having the point z naught to be equal to 3 by 2, and for z plus 3 by 2 you are having the point z naught equal to minus 3 by 2. Okay, don't confuse. Now let's draw this circle. Because it is centered at 1, so I should write here 1. What is the radius? Radius is 1. So my radius is 1 only. If this is 1, then this will be 2. And if this is 1, this will be 0. Making the circle now. Now check the point. Is 3 by 2 lies inside this? What is 3 by 2? 3 by 2 is nothing but 1.5. Yes, 1.5 lies some over here. So this point 3 by 2 lies inside the circle. Is minus 3 by 2 also lies inside the circle? What is minus 3 by 2? This will be minus 1.5. But here in our circle, all the points are positive because 0 is there. So minus 1.5 will be outside. The other point will be minus 1. Then this point lies here. That is minus 3 by 2. Okay. So this point does not lie inside the circle. It is outside the circle. So only one point. That is 3 by 2 lies inside. And taking the denominator, we will include that denominator z plus 3 by 2 inside that fz. Okay. We are not considering the second denominator then. Let's start now. Okay, so what is my integral now? This is, I'm taking 1 by 4 outside and writing 1 over z minus 3 by 2 and z plus 3 by 2 dz. Now what is my function? Take function to be equal to 1 over 4 z plus 3 by 2. Why I have taken z plus 3 by 2? Because for this z0 is minus 3 by 2 and that lies outside the circle. So I have to consider the second denominator in fz. So my fz will be 1 by 4 into z plus 3 by 2. Then what I need? F of z0. Okay, first I write this integral for you. The integral will become C f of z over z minus 3 by 2 dz. Now is it clear? My fz is 1 over 4 z minus z plus 3 by 2 and that is f of z over, now the remaining only z minus 3 by 2 is remain there. Okay, so now we need f of 3 by 2 and f of 3 by 2 comes out to be 1 over 12. Now since fz is analytic, inside and on mod z, not mod z, mod of z minus 1 is equal to 1 and the point z equal to 3 by 2 lies inside it. So by using Cauchy's first integral formula, this will be equal to 2 pi iota into f of 3 by 2 and that comes out to be, if you solve, this will be pi iota over 6. Is this thing is clear to all of you? Okay. Next. Evaluate integral for e the power 2z over z plus 1 z minus 2 whole square, and now the circle is given to be mod z is equal to 3. How to do this? Now here your fz is, how do you get your f of z? First check the points whether they lie inside the circle or not. Since from this my point will be z equal to minus 1 and from this what is my point? Z is equal to 2. Now both these points lie inside this circle, mod z is equal to 3. So my fz will be only e the power 2z. If suppose this point does not lie, suppose this point is, suppose this denominator is z plus 5, then z equal to minus 5. This does not lie inside the circle. So my fz will become e the power 2z over z plus 5. I will take this denominator in my fz. Okay. Now because this minus 1 also lie inside the circle and 2 also lie inside the circle, so my fz will only e the power 2z. So now circle is mod z is equal to 3. Let's solve this. We have to separate the denominators first. Okay. Instead of writing again and again, I just first separate the terms. 1 over z plus 1 and this is z minus 1 square. This can be written as 1 over z minus, sorry, this is z minus 2, sorry. This is z minus 2 and 1 over z plus 1 and z minus 2. I take z minus 2 over here and taking the other z minus 2 with z plus 1. Okay, so this is equal to 1 over z minus 2. Just separate this now. This will be 1 over z minus 2 minus 1 over z plus 1. Alright, then this is equal to, and also 1 by 3 is also there. I'm taking that 3 outside. So this is 1 over 3 integral. Now this will be 1 over z minus 2 whole square and minus 1 over z minus 2 and z plus 1. Again we have to separate this, which is equal to 1 over 3 1 over z minus 2 whole square minus, again if you separate this by the same technique which I have told to you, explained to you, minus 1 over z plus 1. Now you're having the final expression as 1 over z minus 2 whole square minus 1 over 3 into z minus 2 plus 1 over 3 z plus 1. Alright, this is your final expression. Now I'm using the integrals. Now what are my points? Now here in the first one we will use Cauchy's integral formula because power is greater than 1. And in the second one, 2 lies inside the circle, we use Cauchy's first integral formula. And in the third one, z equal to minus 1. Minus 1 also lie inside. Mod z equal to 3, we will use again here Cauchy's first integral formula. And what is my fz for all these 3 terms? My fz for this is also 1. For the second one, fz is also 1. For the third one, fz is 1. So just writing this with integrals. Integral over c e the power 2z over z plus 1 and z minus 2 dz. Okay, fz is now e the power 2z. It is given, it is mentioned. So for all these expressions, fz is e the power 2z. Now this is equal to 1 over 3 integral over c e the power 2z over z minus 2 whole square dz minus 1 over 3 integral e the power 2z over z minus 2 dz, then is plus 1 by 3 integral over c e the power 2z over z plus 1 dz. Alright, now let f of z is for this also e the power 2z, for this also e the power 2z, and for the third one is also f is e the power 2z. So e the power 2z. For the first we need f of 2. So f of 2 comes out to be e the power 4. And for the second one we need again f of 2. Done. And for the third we need f of minus 1. So f of minus 1 is equal to e the power minus 2. Now one thing more. Because we have to use Cauchy's integral formula over here and the denominator power is 2, we need f dash z also. So what is f dash z? This is e the power 2z into 2. And now f dash 2. This is 2 into e the power 4. Alright, now since fz is analytic everywhere inside and on, you just write that line, and on mod z equal to 3 and the points z equal to 2 and minus 1 lies inside the circle, mod z is equal to 3. So by Cauchy's first integral formula, just use the formula over here. Integral over c e the power 2z over z plus 1 and z minus 2 dz is equal to. For the first expression, for the first term, you use Cauchy's integral formula, and that will be 2 pi iota over 1 factorial into f dash 2. Okay, now the turn for the Cauchy's integral formula. Denominator is 1, which is 2 pi iota and f of 2. Then plus 1 by 3, 2 pi iota and f of minus 1. Right? So the final answer will be, if you calculate, 2 pi iota over 9, 5 e the power 4 plus e the power minus 2. Here ends up the solutions and exercises problems. Now I will be giving as an assignment for you, that is the first one, just solve all these. Answer is given. In the first one, I have to tell you that your circle is mod z is equal to 2 and the point is z equal to, your z naught is pi by 2. Now in this case, is pi by 2 lies inside the circle or not? Now pi by 2 is in radians. It is in degree, so you have to change that in radians first. So pi by 2 in radians is 1.57. So it lies inside mod z equal to 2. Okay, and your fz will be z minus 3 cos z. Fine. So whenever the degree is given, you have to change that degree into the radians, and then you have to solve that. In the second one also, your mod z is 3 and the point z equal to 2 lies inside 3. So just solve this. This is an easier one. This is also easier one. The denominator will be changed into z minus 1 and z plus 1. And fifth is also easier for you. Just check that this circle centered at minus 1, not at 1. This circle is centered at minus 1. So check whether the points lie inside the circle or not. If not, then take that denominator with your fz. Include that denominator in your fz. Fine. So sixth one is also easier. You can do this. Just similar exercises. So next time some more exercises we also do on Cauchy's integral formula. Do subscribe and like my channel for the latest videos, and in the description box I will be defining my new course, real analysis. That is a part 1, that if anyone needs that course, you can check in the description box. Thank you for watching the video. Goodbye.